check. Let's get hyped for Tiger Beetle. Let's get hyped for Rust. Let's get hyped for Zig. Hello, my name is Brian. I'm here to hack on some Tiger Beetle. So this is a stream where I am working on the Rust client for the Tiger Beetle financial database. Tiger Beetle is written in Zig, and it has clients for speaking to it in all the languages you might want, but not yet in Rust. So this is a project we're doing entirely on stream to create a Rust client for Tiger Beetle. All of the clients for Tiger Beetle are actually bindings to a library called TB client, written in Zig, and same is true for the Rust client. In the future, we might write a pure Rust client, but for now, there's advantages to all the clients using one library for the actual logic. So this is a project that's largely about FFI, unsafe code, concurrency, nice bite-sized Rust project with a lot of real-world Rust topics in it. Presently, we are working on the rework for our pull request. So we've gotten kind of the basic logic and structure for this client done, and we submitted a pull request. And on the last stream, yesterday, we started doing the rework for this. And I went through the pull request, and we went through it on stream and read all the comments. And 3 of the items there, I had a lot of resistance to. So we tabled those for the night, and I took a walk, and I, did some other things. I had a nice dinner. Just let all those kind of, flow through me and see how I could process all the things that I didn't feel immediately happy to just comply with in the review. And the others, the easy stuff, we knocked out yesterday. But today we're coming back and doing some of the harder stuff. So that's the task for the stream today, is to knock out a few more of these rework requests on the pull request. So let's just get going, and we'll go back to the pull request and just kind of really quickly review what needs to be done still. So here's the pull request. And my reviewer on this pull request is Matt Clad, Alexei Kladov, I think, Rust Genius. And he's very brilliant at Rust and knows all the Rust stuff. And let's go ahead and just see the 3 things here that we have left to do. I'm not going to talk about them at length. Kind of just got to get going and start tackling some of them. All right, this first one here is about bindgen. So bindgen is the kind of standard generator for creating Rust bindings to C code. It looks at C header files and emits Rust declarations, FFI declarations. And the request here is to not use bindgen because it's a pretty big dependency. And also in tree in Tiger Beetle, the existing pattern for the other clients is to write a little custom bindings generator in Zig that uses Zig's compile time reflection to just emit the Tiger Beetle specific definitions for individual languages. So that's the request here, is that we kind of go follow that pattern and write a little custom bindings generator. And this next one here is, what is this? Oh, just a comment, not a request. Just some discussion going on there. This one here is a request about not doing conversions between C types and Rust types. So in Tiger Beetle, there's some core data types. There's some core data types in Tiger Beetle, and they have a well-defined ABI. And those data types are kind of used all throughout the stack, all the way from like the core of the Tiger Beetle engine all the way through the clients. And in my Rust code, I defined like equivalent, more or less equivalent Rust types for those C types. Kind of on the theory that I would rather expose, Rust types and not say anything about the ABIs for a Rust program. But this request is kind of to not do that, to just expose those C types all the way up through the Rust API. Hey, Coda Misanthrope. Yeah, we're going back to our PR review. We're going to rework some of the hard stuff today. So yesterday was the easy stuff. Today is going to be starting on the hard stuff. I think we probably won't finish today because some of this rework is a little challenging. All right, and so this third one is about kind of a pattern for handling one-off signals between threads. So in this bindings, there's 2 threads involved. And when some unit of work is done, I send a message from one thread to the other thread, but that message doesn't carry any data. So you can see here in this code, this is a channel. This is probably a one-shot channel in Rust, where you can send one message and then the channel is spent. And because this doesn't need to convey any data through this message, I use the unit type, which is just a type with one value that has no particular meaning. Just send a signal to the other thread. And my reviewer here, MattClad, is suggesting a different pattern for this, where we use, instead of sending a message, we just use the channel close status as the indication that the message or that the other thread's operation is complete. And this infallible type here is a type that can't be instantiated. So by creating a channel of this infallible type, you're kind of asserting in the type system, you're ensuring in the type system that we're not going to send a message on this channel. We're just going to use this channel for its openness and closedness. All right, so what I think I wanted to do today, this third one, this is the easiest for me to do. It's just a matter of changing a little code, and this doesn't affect the API, so I'm pretty okay with just doing this. So I'm going to go ahead and knock this one out, changing this channel, how this channel is used. I'm going to try not to push back on any of this. I'm just going to do it. Yesterday I was a little bit cynical in my response. I tried not to be, but some of these I was like, but I'm just going to go ahead and, accept this. And I'm going to do also this one about bindgen. I'm going to get started on this. This is going to be tough. So we're going to have to, basically, we're going to write a bindings generator in Zig today, which is nice because we finally get to do some Zig on stream. This is going to be a Rust plus Zig stream, all the best stuff. All right, so I want to note where this is in the code. This is in library, lib.rs, line 254. And probably this is the only place we're doing this, but we'll check. This channel of nil, we want to make a channel of infallible. All right, so let's go ahead and go to the code and just get going. So if we go to lib.rs, let's see where we're creating channels here. This is probably, yeah, this is the one he commented on. This is a different channel that actually has a value. So it looks like this is it. So here, instead of doing a channel of nil, we're just going to do a channel of infallible. Looks like I need to refresh my buffer. And then, really quick, I'm going to see what this channel is actually used for, so make sure we're going to be testing it correctly. This is in the close method. So this is basically a signal that we have done the dinit. So this is an async API. In this close method, the underlying TB client dinit function is a blocking function. So this close method, creates another thread just to call dinit on the underlying client. And the signal we're sending is an indication that that blocking dinit is finally finished. All right, so we need to import that infallible. It's somewhere up here. Convert infallible, ubble, ibble. I'm going to say ibble. Infallible. So down here, the way we're using this is we're not going to send anything. We're just going to drop it. And I'm going to do this explicitly just to indicate that, we are intentionally doing something here. Like this will go out of scope and drop automatically. The destructor will be run automatically. But because we're kind of using drop for a side effect here, and it's an important part of the logic, I'm going to explicitly call drop here. We'll see how that reviews. And then down here, we're going to await still. We're going to wait on some kind of result, but we're not going to insist that it's a good result. In fact, it's going to be a bad result. Or we're going to receive an error from the channel because the sender never sent anything. So here, actually, what we kind of want to do is we could assert that there's an error, but I don't feel like it's really necessary. Like the sending code is here and the receiving code is here. There's not a lot of distance between these two operations. And just looking at this, I'm kind of like, I'm not going to complain too much on the stream, y'all, but kind of non-obvious. This is kind of non-obvious to me. And I'm going to put a comment here because it's not obvious. Wait for the channel to close. And we can probably just run the test suite. And this should work no problem. And we have to run Clippy because Clippy might not be happy with that explicit drop. There are occasions where Clippy does not like you just explicitly dropping things. Infallible. Yeah, okay. Fell victim to the ubble-ibble conundrum here. It's infallible, not infallible. Okay, looks like our smoke test passed. And I'm going to say commit this, rework, change message passing pattern. And now we're going to run cargo format to make sure format's still happy. It is, and I'm going to run cargo Clippy here as well. I don't remember if we were clean from cargo Clippy before this or not. But let's see what Clippy says about that drop, if anything. I have some new activities to do today while we're waiting for builds, so we'll see if I get bored of waiting for builds. problem with this project is the builds are not long enough to actually go stop and do something else. They're just kind of long enough to interrupt the flow. Hold on, let me adjust my AV 1 second here. I'm a little too hot in my cans. All right, let's try that. Oh, now I'm quiet in my cans. Let's try that. Check, check, check. Okay, Clippy's happy. That's great. I'm going to push this. I'm going to just push. And now let's go do the bindings generation. This is going to be our big project for today. And I suspect we're not going to finish today. Because it's going to be a big project, I'm going to create a new branch just for this. Check out branch, Rust client, bind work. That seems like a okay name. Now, let's go kind of like collect all the resources that we're going to need to reference to make this happen. So in our clients directory, we can see the way that other clients work. I think all of these have a file. If it's not named exactly like this, then it at least functions like this. There's a Zig program here that generates bindings for Go. This is in the Go client directory. You can see there's also another Zig program that generates some kind of docs for the Go client. So these Go bindings, you can see here some types, and they're going to use reflection here. Here's a comp time type in this Zig function. They're going to do some reflection, compile time reflection over these types in order to generate Go code. And this Go code ends up going probably right here. This TB client looks like this is probably, no, is this auto-generated code? No, this looks handwritten. Where does that Go code go? I bet if we look down here, right, there's a warning here. This is auto-generated. So if we go grep that, create a new directory here, I can go grep things in. Go bindings. Here's where the Go bindings show up. Go package types bindings. So this is the bindings generator. This is the code that is generated by the bindings generator. Package types bindings. Here you go. Let's see if I have a Go mode in my Emacs. Does not look like it. Sorry, chat. No Go highlighting for you. Let's go. We're not going to look at much Go code today. I don't need Go highlighting. So you can see here, generated code. And supposedly the Go bindings are pretty straightforward, a good cross-reference. But I happen to think that we're going to care about the C bindings generator more. And so if we go look at, after all, we're already just using the C bindings generator to generate the Rust client right now. So right now, the way this works is that we have bindgen, the Rust bindings generator looks at the TB client header file, which is generated from the Zig C bindings generator. So we have kind of two level of automatic bindings generation. That's one of the complaints in the review is let's not have two layers of bindings. But if we go look at the C bindings, this TB client, this is like the header file for C programs generated. And this is generated by TB client header.zig. So what I suspect, what I think I want to do is basically copy and paste this file. You can see this is, again, very similar in structure. I suspect these bindings generators all kind of get copy and pasted around, which we're going to do too. Bunch more types here. You can see there's, curiously more types in the Go bindings generator. And if we look at the main function, we can look a little bit about what this program does. Here's main. So this is a program that gets run by the Zig Tiger Beetle build script. I don't know what this does. I think we'll probably go read the docs for that at some point today. Interesting, right? But what it does is, it prints some just standard C header stuff, which also is paired with some C footer stuff. And then basically the only thing it does is it iterates over types, Zig types, and then does, something with those Zig types. And it's language specific. And then these are the functions, and these bindings generators are not clever enough to auto-generate the function bindings yet. So you can see here, there's a comment here that's like probably related to actually generating these, but right now it's just output by hand. So we'll probably do a very similar thing, just splat some handwritten function declarations into our Rust bindings. And all of these, but this looks pretty straightforward, just 259 lines of code. And all of these are driven through the Tiger Beetle build system. So let's go over to Tiger Beetle. Now at the top level of Tiger Beetle, there's build.zig. And if we look through clients, all right, so here's a bunch of different rules for building client stuff. And right now we don't have a Rust one here at all because the Rust client is just piggybacking off the C client bindings. We build inside of the Rust build script, we call, in the case where the Rust build is being built from the Tiger Beetle code base, we call the Tiger Beetle build to generate the tbclients.h file that we just looked at. And this clients.c, let's go see what's in that, but it is going to call that bindings generator in addition to other things. Build C client here. So, okay, that's still pretty small amount of code, but we're gonna end up wanting a build Rust client to drive the Rust bindings generator. I'm just looking real quick to see if there's anything surprising in here. TB client header step. Not sure what this is. Let's open another copy of build.zig in the other window. Client header. TB client header generator. Honestly, this might be the only thing we need. So build C client is going to also build like a static C library for a static C library. And we will probably keep using this build step because we're linking to that C library and we don't need anything special with this library for the Rust build. We'll see. But this depends on the C client header step. So this is probably the actual thing we need to look at for how to generate the Rust bindings. I'm just searching for how this is used. Okay, so the Python client also seems to depend on the C client header. C client header, build C client header. Depend on C client header step. TB client header. Just trying to figure out where this is. Add executable TB client header.zig. So something like this is what we need to do for the Rust bindings. I'm guessing this is broken out like it is because multiple bindings depend on that C header. If we go look at the Go bindings, client Go, Go client, build Go client. This also seems to depend on the C header. Interesting. Build Go client. And then here inside of build Go client, it updates the generated header file. I don't know what that is offhand, but here it runs that, it builds and runs that go bindings.zig file. So maybe for the purpose of the Rust client, we will do something like this. And I bet this also, does the Go client depend on building the C library? It depends on building the header copy. This is just copying the TB client header after it's been built by the C client. Let's go back up and look at the Go client declaration again. Build Go client. A lot of this stream is just going to be kind of understanding how the Tiger Beetle build works and copying around code to introduce a similar thing for the Rust client. Client Go depends on the TB client header path. So what I'm expecting here is that in order to build the Go client as of today uses cgo, and it's going to need to link to the TB client library. So I would expect building the Go client to also build the C client. But here, it doesn't really indicate, like I don't see an indicated dependency from the Go client to the C client. Let's go real quick. I may not understand this. I might not achieve understanding of this today. Build Go, build steps clients Go, TB client header. Generator. TB client header. Who else depends on TB client header? The tests require client header. Vortex, a testing system, requires the TB client header. The Go client, interesting. I'm wondering if the build just always builds the TB client library. Let's go back to the Go function build Go client, clients.go, clients Go, bindings generated file. That's the Go bindings generator. This is just copying the library. This is adding the TB client static library to the Go build. But what causes the TB client library to get built? Depend on install file, path join, TB lib, out file name, static library, link libc. I am not entirely sure how this all works. I suspect that this is not actually building the Go client. This is just building the library, the static library necessary to build the Go client. I don't see any invocations of the Go tool here. Interesting. So I'm wondering if I should actually build add install file lib get emitted bin TB client. Yeah, so this is building, I think this is building a static library called TB client. So like there are multiple ways to build the TB client library. Basically every client bindings builds its own copy of the TB client library. Possibly customized for that language. Like you can see here, there's flags being flipped on for the TB client library for the Go bindings. And we don't need that in the Rust bindings. Like right now, we're just linking to the standard TB client C build. but maybe for consistency here, we should build TB client ourselves. Anyway, let's just get going. Let's start making so I think the way I want to do this, let me step back and think here for a second. I don't want to just immediately throw away the working bindings. So we're probably going to have two sets of bindings while I develop the new bindings. And there's two build systems involved here. And right now, building the Rust bindings involves running cargo in the Rust client directory. And the Rust build script invokes the Zig build script in order to generate that header file, the C header file. So probably in parallel to generating that C header file, we'll also have the Rust build script run like Zig build client (Rust). So right now it runs Zig build client (C) to build the header file, then copies that header file into the Rust build directory, the Rust source directory. I'm probably going to have another step where the Rust build script runs client build clients (Rust) to do whatever Rust specific stuff is necessary, which is going to end up being running a code generator for Rust. So we'll keep driving the entire Rust client build through cargo. And we're going to have to add a build target to Tiger Beetle to build that Rust clients generator and build and run the Rust bindings generator. That makes sense, right? All right, so first thing I'm going to do is I'm going to go modify cargo, the build script in cargo, to also run a Tiger Beetle build target for Rust and copy in place the hopeful output of that, which is going to be a Rust file, generated Rust file that is the bindings, into the Rust directory. No, we're not going to need to copy it because the way these build targets for bindings work in Tiger Beetle is that they output the bindings into the client source directory. So we're going to do that. So we're just going to have the cargo run Zig build clients Rust. And then we're going to copy probably the build target for Go into a target for Rust. And then we're just going to go from there, see what happens. I might need help with this because as you know, I don't really know Zig. I know a little Zig. Let's go make it happen. All right, we're looking at the source code on stream. First thing to do is modify our build script. Source Rust. Nope. Clients Rust build. Okay, here's our build script. Somewhere in here, we're running clients C, all right, build targets. What is this function here? Build Tiger Beetle. Build targets clients, build targets install. And this only happens, I think, if we're in tree. All right, this is build Tiger Beetle is called from prepare dependencies. And you can see prepare dependencies says if we're in the source tree, the Tiger Beetle source tree, do one thing. If we're not in the source tree, do something else to be determined in the future. That's for the case where the user is installing their Rust dependencies from crates.io, or they don't have access to the Tiger Beetle source code. And what we're going to do there is we're just going to package the static libraries with the Rust crate. Okay, so build targets to do clients.c. So we're just going to add another one. It says clients Rust. And that's really all we're going to need here. Oops. So this is going to build the TB client library. This also builds the header file. And tbclient.h. And we're going to get rid of this eventually. So at the end of this project, this is going to do everything we need. Build the TB client library and tbclient.rs. And if we go look here, this tbclient.rs is what we're using right now, generated by bindgen. So we're just going to have our own bindings generator do this. So if we go run the Rust build right now, this is going to fail because that build target doesn't exist. Let's see how it fails. No step named clients Rust. Okay, that's easy enough. Now I think for now, I was thinking about whether I want to change directories here and drive the Zig build directly while we're testing, but I think I can just keep running cargo build to drive the Zig build. This looks more or less comprehensible. All right, let's go back to build.zig. Well, before we do that, let's think about what we want here. Probably what we're going to want here, this is our Rust directory, is going to want a rust bindings.zig. So I'm just going to make that exist. Rust bindings.zig. And then in our source directory, we're going to have, actually, in our source directory, this Rust bindings generator in Zig is going to output tbclient.rs. Though in the short term, we're going to have two bindings generators running at the same time. We'll probably call this the new one tbclient2.rs. And eventually, you can see our assets directory here. This is where our current build script copies the tbclient library to. And this tbclient.h similarly is copied from the Zig client-c build into the Rust directory, because this is all going to need to be packaged with the crate eventually. So to include any kind of assets with a crate, they have to be in the same directory as the crate. That's why we copy them all into the subtree here. You can see here, these are all static libraries for all of the supported Tiger Beetle targets. And so we're also going to want our Zig build client's Rust target to generate these libraries and put them right here. But we'll do that next, because currently that's the C build is already doing that successfully. The first thing we're going to do is teach the Zig build to run this Rust bindings generator right here. So next I'm going to go look at the build go client function here. I'm going to make a similar thing called build Rust client. So basically everything that this does, actually I'm thinking about like how much I want to copy and how much I just want to stub out. And I think we're not going to want to copy most of this logic here, but who knows. For now, I'm just, for the sake of having this code near the code I'm going to cross-reference, I'm going to define my function right next to Go client. So it's going to be called build Rust client. And let's go see where build Go client is called right here. Copy this call as well. It's going to say build Rust client. Build steps client. Okay, we got to go add this build step client Rust. This all looks like probably what I'm going to need still. And clients go, copy this, make another build step for Rust. This is going to build the Rust client shared library. And then in build Rust client, I'm just going to say panic. Sorry, I'm always getting confused between Zig syntaxes and Rust syntaxes. Is there a to-do at to-do in Zig? I don't remember. And can I leave this blank? I don't know. We'll see. I'm just going to see if this builds now. Build clients Rust. And I have a special build of Zig here that's going to allow unused arguments, and I'm curious to see if it works. Okay, gonna pass an argument to Zig's panic. This is where it's gonna get interesting, y'all, because everything in Zig I write is going to be wrong. So if you're just joining us, this is a stream where I am working on the Rust client to the Tiger Beetle financial database. Tiger Beetle is written in Zig, but Tiger Beetle is written in Zig, and this is a project to write a client in Rust. And right now I'm doing some rework on my PR for this client. And on this stream, I am writing a Rust bindings generator in Zig. So we're going to be running some Zig code to generate Rust code to bind to the CABI TB client library, which is written in Zig. I hope that's clear. All right, and you can see here, okay, this ran and it hit my panic. Great. And also you can see that we have some warnings here about unused functions. That's great. All right, so now the thing we have to do is make this Rust client target do something useful. And I think for now, somehow this build script, we've looked through it a little today, it seems to always generate this C header file. In the Go client code here, when you build the Go client, it just copies this header file into place. So we're going to do exactly that here. And for now, that should be all we need. We just have to remember exactly where it goes, which is our Rust directory assets. So we're going to copy it right there. But actually, I don't think the Rust code is going to need the TB client at all. Like once we generate the bindings, we're not going to need the C header file, right? The CGo build for the Go client, actually, the way CGo seems to work, I don't know Go at all, pretty much, is that it does parse the TB client header file. But for the Rust bindings, we're just going to output Rust and completely discard this header file. So actually, we don't need this. Build Rust client. This does not matter to us, I think. What we do need to do is run a program. So right here, build.zig, we're already in build.zig, go bindings generator. This, we need to do something like this, for Rust. So let's just copy this into place. And then we'll put another to-do right here. And then look at what this does and think a little about how this can be translated to Rust. So this is a Rust bindings generator. This is a program written in Zig that runs at build time called Rust bindings. The source file, just like Go, is going to be in the Rust client directory called Rust bindings. And we've already touched this file, but right now it's empty. Target b.graph.host. Don't know what that means, but we are, okay, I can guess what this means. I don't know what graph means here, but it's probably a build graph because this B is a build object. The host is certainly the host architecture, like a host target triple or some target specification that defines the platform we are running the build on. And we're just copying the target for our Rust bindings program to be that same because we're going to run this on the host. All right, the root module, we're going to add a dependency here. That all seems to make sense. Root module, we're going to add VSR options. So VSR is the state replication, something state replication. It is kind of the state machine for Tiger Beetle, kind of the core engine. And this is gonna, we don't need to care about the TB client header for the Rust bindings generator, I believe. Generated file, bindings. We're declaring that one of our build artifacts is a file here, I presume. This is all APIs in the Zig build system. So the Zig standard library basically comes with a build system that you can drive programmatically. And that's how you build Zig code, is you write a build script and you instantiate a build system. And this seems to be declaring like an element in the build graph that says this is something that we've generated. And the path here is going to be Rust. And let's see again, let's look at our Rust directory. We could put this in assets, but right now we have it in the source directory generated right here. So we're going to put this new bindings right next to that file. Rust source. We're going to call this tbclient2.rs. And then once we've got it all working with the new bindings, we'll just rename this to TB client and delete the old code paths. Let's see if this builds. Let's see. Activities I can do while we're waiting for the build. Yeah, it's done already. Okay, it built and ran. So hit our panic there, or to-do panic. Let's go back and look at the Go code again. So after it declares the bindings, it does some stuff. I'm feeling like I probably don't care about this stuff for the most part. What is platforms? What is platforms here? A constant probably. I don't see a platforms argument. Const platforms. Okay, right there, platforms. This is all of the targets that Tiger Beetle supports. So what is this doing? Cross target, resolved target, add static library. So this for all the supported platforms that they care about for the Go bindings, it's adding a step to build the C libraries, dependent on binding step. Why does this depend on the binding step? So I think this is just building the C library. Depend on. But the building the C library seems to depend on building the bindings, which, you know, maybe it doesn't matter, but that doesn't make sense to me. Again, this step does not build the Go library. This just builds the bindings declarations for Go and the declarations, the FFI declarations, and the C library that the Go build needs. Yeah, I guess it just makes sense. Like the bindings need to be built somewhere. So you might as well make it a dependency of the library. So I think I don't really step clients.go depend on that. For now, I don't want to rebuild the C static library yet. Right now, I just want to build the bindings, and then in a separate step, I want to come back. So I don't think I want to do any of this, because this is all about adjusting the configuration of the static library per platform. think what I want to do is something more like this. More like that. Actually, where does this actually run the bindings? Binding step. Okay, so this file depends on the bindings generator. The bindings generator is an executable. Does declaring an executable run that executable? Source file target host bindings generator. Now, this generator, this generated build step, presumably it has a dependency on a generator. So this is probably the thing that runs the generator that we built. So I think all I really want to do is, for now, add a dependency to our Rust client that is this bindings, just like this right here. So I want to say steps clients Rust depend on those bindings. So when somebody builds the clients.rust, clients:/rust build target in Zig, it'll run this function and declare that our build step, our clients Rust build step, depends on this bindings file existing, and this bindings depends on this generator. So this step will run this generator that is a dependency, which will build the bindings generator. That all looks more or less correct. So if we do this now, what I'm suspecting is, once we get this to compile, that this will build and run, and because our rust bindings.zig file is empty, we'll get some kind of compile error when we try to compile the bindings generator. And I think I actually don't want to be in the Rust directory anymore, driving cargo. Oh, that's interesting, though. I didn't actually know this. So I am in the Rust directory. This is a subdirectory of Tiger Beetle, but I can run the Zig build from this subdirectory. I didn't know that. That's a nice thing to do. So I can say Zig build clients Rust. Let's see what happens. Okay, some kind of compiler error. Steps clients Rust does not exist. Step clients Rust. Just a typo. All right, and no field step in build step. Why did I get that wrong? Step clients go lib.step. Gotcha. Okay. No step right here. This is a step. Now this should attempt to run the build for the Rust bindings generator. Yeah, okay, you can see right here, the error we got is that there's no main function in Rust bindings. Perfect. That's exactly what we expected. I'm going to kind of checkpoint my work here. This is good progress. And let's open up Rust bindings and open up, I think I want the TB client header. I'm not going to copy the Go bindings. I'm going to copy the Rust bindings. I'm not going to just copy everything straight away. What I want to do instead is just stub out a main function. And I'm curious how this decides where to write, because right here you can see we're just writing to a buffer. And down here, okay, so the bindings generator writes the standard out, and then the build script somehow redirects standard out to the desired generated file location. Maybe that's all part of the generated build target in the Zig build system. I don't know. But this is pretty straightforward. So I'm going to say main. And I'm going to copy parts of this. I'm not just going to copy the whole thing. I want to do it incrementally so I kind of understand from front to back how this works. I'm not just going to copy the whole file and then piecewise change stuff. We know we need an arena allocator. We know we need some kind of allocator. Probably need some imports up here. I'll go ahead and take all the imports. And then we know we're going to need a buffer. And then we know we're going to need to write that buffer. So this is going to be a Rust file that we're writing. And I'll go ahead and write some kind of thing here, like this prelude warning thing. And this multi-line Zig string syntax right here with these 2 backslashes. It's kind of a nice syntax. I think I like that. Although my editor didn't understand it. This is probably good enough to start. So if this succeeds, we will get an output file that looks like this. So let's see if this runs. Buffer member function expected 2 arguments. Right, of course. Printing functions take a second argument second argument that contains arguments, like string formatting arguments. So right here, oh, you can see my editor hates this. Whatever. At the end, we're going to run a Zig format over everything, and it's just going to do whatever it wants to do. Okay, so our bindings generator ran up seemingly. So if we go back to our source code for Rust, there's a TB client 2 here, and it contains this little warning. Great. And I want to go back and look at the TB client header. Okay, there's a couple extra lines here. We want to do that as well. And this is, okay, this TB client 2, we do want to check in. We do want to check in the client bindings. I think. I'm not entirely sure, actually. Let's see what we're doing with the old client bindings in Rust. We might not actually want to check those in. Okay, so we are ignoring the old bindings, so we can ignore the new bindings as well for now. And eventually we have to come back and get rid of that. Let's say get status. Okay. And we're just going to checkpoint. Every little step of progress I make, I'm going to commit. All to temporary commits. Now, I think is the time to go read some docs and figure out what set eval branch quota is. Let's guess first. Set eval branch quota. Okay, my guess, this is a limit on compile time looping, like to prevent infinite loops at compile time. That's what I'm guessing this does. Let's go look. Ziglang downloads. I could ask ChatGPT or a search engine, but these download, that's not where I want to be. Documentation. The LLMs are not very good at Zig yet. So here, one really nice thing about the Zig reference is it's all one big page, so we can just do a regular old search. Set branch, not set branch, what was it called? Set eval branch quota, eval branch quota. Increase the number of backwards branches the compile time code can use before giving up. Okay, exactly what we guessed. So it stops infinite loops. I wonder why that exists here. I don't feel like I'm going to write any infinite loops. I don't feel like I'm going to write infinite loops. Let's see how else this is used in the Tiger Beetle code base. Let's go back to the code so you can see what I'm looking at. RG set eval. RG set eval. Oh, it's used everywhere. Not everywhere, just all over the place. Ah, gotcha. And so no SIAM, you're mentioning that like if you're using a lot of comp time, this limit is low normally. So if you're using a lot of comp time, you got to raise the limit. That's also true in Rust macros. If you do a lot of stuff at compile time, there are just limits set by default. And if you do a lot, you got to raise those limits. That makes sense. Thank you. Thank you for the help. I am going to start by not using that, and we'll just see what happens. Okay, so now we got to do something for type mappings. We got to define some type mappings. And I'm going to use the same type mappings as C. But I also want to really quick compare the type mappings in the C generator to the Go generator. Because I think these arrays are different in the Go generating. Okay, you can see, yeah, here. Create account result. Create account result. Huh. Gotcha. Right, so these strings here are going to be the name of the Rust type. And then the Go bindings are structured slightly differently here. Probably because these two types need to be related in Go, like through a generic maybe, or an associated type in Rust. Not sure though. Like maybe create account result needs to mention the account type as well. You can see there's also a mapping here for the account type. So that's probably the case, that this account result also needs to mention account. So what we can do here is go look at our existing Rust code and just kind of transcribe the names that bindgen gave to these types. Actually, probably not, because, well, we can go look, but we generated the Rust bindings, our existing Rust bindings, from the C bindings. And so these types are probably all going to be exactly the same names that we're already using. We can go kind of poke around the existing Rust bindings and see if that's true or not. So if we go look at like TB account flags, actually I already know like this is the name that we're using for account, TB account T. And it's interesting, we could, or these are just types, right? Type names have no representation at runtime, right? Names are just for the source code. So this could be named anything in any other language. It doesn't matter. It's not true of function names. Function names, exist as symbols, but types don't actually have names at runtime. So we could, give these names that are more rusty if we wanted to. I kind of don't want to, and at least for now, when we're doing this transitional step, I want to keep the exact same names to make the transition between one generator to the other generator easy. But we could come back and give these rusty names. Or keep the exact Zig names, because these type names in Zig, account flags, this is exactly the Rust naming convention as well. this, what is this doing? TB operation, TB pack. This is seemingly taking the C declarations for some types and doing some kind of bindings to them, which makes sense. Let's go look at what this TB client is. I think TB client in this case is the Zig library for the TB client library. Let's see if we have that buffer open yet. No, we don't. I think this exists in the VSR directory, TB, no. Well, TB client exports. Let's find that TB client module. TB client, clients, okay, so it exists in the C directory. So the core VSR module includes the definitions from the CTB client library. It's kind of interesting to note, I guess. Let's go look at it. Source, client C. So this is maybe not the entry point to the TB client library, but there's a lot of the declarations. And you can see the C generator is including this module and then doing some compile time reflection over some of the declarations in this library. Ooh, my hand is kind of cramping up. That's unusual. Let's go to TB operation. TB operation. State machine operation. TB packet status. TB packet T comes from TB client packet.zig. Okay. Yeah, I'm pretty happy with what I'm seeing here. I'm just going to keep this exact list and generate bindings, generate Rust definitions of all these types using the same C type names as the C bindings for now. So let's go back to the C bindings file, which is TB client, oopsies, TB client header. And we need to create a little loop that does something. So what this does, I'm going to guess, because this is some sophisticated Zig stuff that I don't really have any experience with. It's going to look at the Zig type. So these are actual Zig types, or Zig type values. And that's a string. So here's the Zig type that we're going to reflect over, and there's the string we want to call the Rust type. So let's just keep exactly that. There's going to be so much copy pasting here. And then we're going to do some reflection on the type info. Oops. Okay, and if it's a struct, we do something. I'm going to copy this and then clear out the match arms. Else this. Yeah, I don't think I want to keep any of this arm. I'm going to say panic to do. Yeah, I think I just want to drop all of the arms right now and deal with that later. I'm going to switch on the struct layout. That's, yeah, again, I'm just going to clear all of this out still. Just get this to build, and then we'll go through and think about the cases one by one. Okay, it looks like that built. All right, so in the case of structs and enums are probably the hard cases. This is just, scalar types right here in the else case here. So I'm going to say, see what the C code is doing. It's doing a type def. And it's saying that this resolve C type. All right, it's giving a C type the Zig name. That makes sense. And I can do something very similar there. But instead of resolve C type, it's going to be Rust type. And this syntax is not correct for Rust, so it's going to be type. This is going to be Rust name, C name. I think I did this backwards. What is C name here? No, I did not do that backwards. So the name we're giving it is right here. And there's a type alias. So this is the type alias that we're creating from some Rust type, resolve Rust type. So we can create another function up here that is the equivalent of resolve C type. We're going to call it resolve Rust type. And there's a switch here. I'm going to go ahead and add the unhandled type. And I think I can just build that and see what happens. Unused capture, undeclared identifier. I didn't rename this function. Resolve Rust type. Okay, that worked, and it just hit a panic somewhere. Line 58. I'm curious what panic this was. We got lots of to-dos in here. And this one, so it hit the struct first and panicked. For now, I'm going to get rid of this panic. We're just not going to emit anything because I want this to get down to this case. Okay, so it hit that compile error. So now we need to fill out all these simple cases. We could get this done today. Let's see how motivated I end up being. Resolve C type info child. Huh. So in an array, a Zig array, it's going to resolve the child info. I wonder what that means. So the purpose of this function is just to return a string that looks like the correct Rust type name. And this is the array case. So I'd expect this to be returning, something with some brackets in it, but I don't see that here. Let's see. Compiler error. I wanted the compiler error to tell me what case it's trying to do right now. Any opaque. Oh, that's great. That seems like a tough case. Opaque, right here. A star any opaque. So the pointer case is going to recurse. So this is a pointer to any opaque. It's going to recurse and probably get the inner type and print, some kind of star. Let's go ahead and do the pointer case then. Info.size is not equal slice. Info is allow 0. Seems like assertions we can also use. Don't know if they really matter to us. Now we're going to look at the type mappings again. So we're going to look through all of our type mappings and see if we know about wait, does this recurse? Return comp time C type. All right, so if it's a mapping that we know about, like a struct that we're trying to generate maybe, then we're just going to immediately prefix type struct star. Huh. Don't quite get it. We know for many cases, we're going to want to do this and just recurse and get the type name. And remember, we're generating C code, so this star is backwards. It's going to be a star plus. And in Rust, unsafe pointers need either be constant or mute. Almost certainly mute is what we're going to need. Let's think again before we do the recursion. What is this? Do I really need this? This probably makes sense. Right. It could be recursing quite a lot depending on how deep the types are nested. Yeah, I think we need this. I'm just going to go ahead and do it. And again, this is just copy-paste stuff. And then this is not right for Rust. Don't think Rust is going to need to say struct here. I think all we need to do is say star mute plus the name of that type. Let's see how far this gets us. Unhandled type, runs result type. Where is it? Any opaque. Okay. So we did recurse into the pointer case, and then we saw this any opaque, and we didn't handle it. Where do we not handle it? Right here. Right, so in the C code, there's a case here. After we've recursed into our pointer, void and opaque. Probably the thing we need to do here is say libc c void. And then that means we need to have that libc dependency available. I assume we do. Let's go check though. Let's go check. Clients Rust, cargo.toml. Oh, no libc. C void might be defined in the standard library, though I think we're going to need libc. Let's go ahead and add libc as a dependency to our Tiger Beetle. So we can say cargo add libc. And there it is right there. I think that's enough. Let's see what this does. To really test this, we're going to have to start commenting out some of these type mappings because we don't have most of these cases working. I didn't need to do that again. Oh, it did error. No, it didn't error. It worked. It ran. So that was enough to do all the non-struct cases. That's great. So you can see here we skipped the complicated cases, but the basic built-in scalar types we tried to generate, and we didn't have an error here. This is just a bug in my version of the Zig compiler. There's no actual error here. My Zig compiler has warnings. The normal Zig compiler does not have any kind of like unused value warnings, but there's a little bug here where it says there's an error when there's not. TB client header. Okay, so I want to go look at the TB client 2 RS, and there should be something in here. Okay, and the only thing that's generated, so apparently the only scalar we depend on is this TB client T to be a star void. But this does look correct. There's an extra space at the end. Yeah, this code does have an extra space in it. I don't need that. I'll generate that again and get rid of that space. Okay, no more space. Okay, so that's some progress. This is actually easy, y'all. Just copy pasting. All right, let's checkpoint that work. And let's handle the, wow, I feel like I didn't do much at all for the resolve Rust type. TB client header. I'm forgetting the name of this file. Yeah, we didn't fill in most of this stuff. Okay, what I want to do then is, this is the one we've got working so far. I want to copy out, or I want to comment out everything except one. Just get one of these types generating correctly. Comment region. And then this TB account flags is a struct, I think. Let's go look at it actually. TB client RG const TB account flags. Is that what it was called? Account flags, just account flags. Struct.star. There we go. Oh, no, still not it. How do you grep a struct in Zig? Oh, I'm in the wrong directory. That's how we're not finding anything. I'm in the Rust directory. RG struct count flags. Still haven't found it. Const. There it is. Okay. Const account flags struct. Tigerbeetle.zig. I just want to look what these fields look like and see if they're using any bit fields specifically, which is kind of tough for Rust. Count flags. Okay, so as you can see, it's got packed booleans. So I think these are going to be individual bits, which is a tough thing to do in Rust. So tough that I'm going to punt on this one for now, and we're going to try a different one. Really, what this is going to end up being is just a struct with a single U16 in it, and then a bunch of masks probably to access the individual bits. Let's see what the C bindings look like there. We are copying from the C bindings, so we can probably just do something similar to what the C bindings are doing. Account, oh, it's right here. Yeah. So the C bindings get an enum where these are some kind of bit mask. Yeah. We're probably just going to do something very similar and then let the Rust code deal with bit masks, not try to generate, for example, a bit flags macro. Yeah, this bindings generator is going to be very similar to the C bindings generator. I'm just thinking right now whether I can just deal with this right now or punt and come back later. TB client header. I'm going to look at what they're doing. So they have a type. Okay, Okay, if it's a struct, so this is a struct, but it's a special struct. It's a packed struct with bit fields inside of it. Info layout, auto layout, packed layout. That's what we've got. Emit enum. Going to emit an enum. Padding. Emit enum. Okay, let's look at emit enum. Emit enum. And is this the only place it's called? No, it's also called for enums. How is it called differently? Info, cname, zig type, info. Emit enum takes a zig type, and there's probably a switch on this type because there are two different types of enums. Like one is a struct, one is actually a struct. Packed struct. So there's a special case for packed structs here. Yeah, we can probably just do this. We can probably do it a little bit better than BindGen. We have a little more knowledge than BindGen does, because BindGen kind of mangles this when it translates this to Rust. But at the same time, in order to do this transition, I kind of want to generate the exact same code BindGen generates, or at least the exact same types. BindGen turns these into constants, not embedded in the enum. Yeah, I'm going to punt on this one for now. Come back to it. This is a hard case. Rust bindings. So, not do this one yet. Let's pick something. I think a count. They're going to pick something that doesn't contain a flag struct. So a count contains flags, I think. So if we tackle a count, we're going to have to tackle that at the same time. Look at Tiger Beetle and look at that account. I find Zig somewhat ungreppable. See if I can search for const account. Okay, there it is. Okay, that's not too bad. This is a struct and defined that I had to grep for a const account. And yep, it contains an accounts flag, so I don't want to deal with that yet. Create account result. Const create account result. It's a U32. It's an enum. I'm really kind of wondering here. I'm feeling like I'm going to end up generating bindings that are more Rust-like and less C-like. Kind of dreading this right now. Kind of dreading this. Because in the Rust bindings, tb client.rs, create account result is not a Rust enum. It's just a whole bunch of constants. And so what we're looking at here is we might end up creating a bindings generator that acts like BindGen and converts these enums into just a bunch of constants, then throw away the BindGen code path, and then rework our bindings generator code path to generate better Rust code. It's kind of not liking that prospect, but I feel like that's where we are, because we're going to basically write a bindings generator that we're going to throw away a bunch of it because it's not going to generate the correct code. But let's bite the bullet and try to make this create accounts result do the right thing. Create account result. Create account result. Okay, that's what we want. Let's do this create account result. And so this should fail by hitting one of the enum code paths. Actually, it's not going to fail because right here, we commented out these panics, these to-dos. This should fail right there. Let's run that and see what happens. Looks like that's what happened. Line 77, line 77, okay. So we need to start filling out this enum code path. And to do that, I need to look at the C generator. And what it does is this. Huh. What is this? Skip. This is an array of an array, or a slice of a slice. If Zig type is this thing, we're just gonna so there's a special case for the TB operation enum. So what I'm going to do is not do that. I'm just going to put a placeholder in here so we don't forget to do that in the future. Some kind of special case right here. That's not lovely. Okay, here we're going to emit an enum. That's all we got to do. I'm going to say, literally copy that code. And this skip needs a definition. And go look at emit enum, copy that signature. Where does this live in the file? Okay, that lives after resolve Rust type. And we'll just to do here, go see if this builds. Panicked at 57, which is right here. Okay, let's see what they're doing. All right, so this is the, we think our bindings are, I think ours is going to be different than this for sure, because we are trying to emulate bindgen. Let's go look at the bindings code for, let's look at the bindgen bindings code for account. Oh, shoot. Account TB create account result. TB create. So this is what it does to TB create account result. And we need to emulate this. So there's a type def for TB create account result and then a bunch of constants. Let's look at probably type TB right there. So it's defining these C enum types as C uints, which is correct in the general case. Generally, C enum turns into unsigned 32-bit integers. Okay, so we have to define the type, and we have to define constants for every variant. Let's look at our suffix. Do we care about this? Last index of CNAME, suffix position. This does not look very relevant to me. Suffix position. What is a suffix position here? Possibly just getting indentation correctly? No, no. Yes, no. This is trimming something off of the CNAME. Maybe removing like a _T or something like that. unclear. Anyway, the first thing I want to do is emit the type def, which is something like this. And this is going to be Rust type CNAME, and this should be Rust name. Equals libc. Actually, let's see. I think this uint type also lives in the standard library. Yes, OS raw. And probably our void type also lives somewhere in the standard library. Let's see if bindgen agrees. Yeah. So some basic C types do live in the standard library. So we might not actually need the libc import at all. So it's our, let's see, where else did I use libc? Right here. This is actually stud os raw. And we can go remove that libc dependency for now because actually we don't need it yet. Maybe we won't need it. And then when we defined our enum type, this is going to be a stud os raw cuint. And now we just have to emit constants for every enum. TB client header. I wonder if this has to be inline 4 or not. Type info fields. So we're going to do something for all of the fields of this enum. And then after this, we probably don't need to write anything, but we can throw in a new line because we're not generating an enum, we're just generating constants. But an extra new line will help visually. We don't need anything there. Okay, I feel like I'm starting to lose a little steam here. We'll see how much further we can get. So what does the C bindings do with the fields? Resolve C type. Right. Don't feel like we're going to need that. Oh, this is emit struct. We need emit enum. This makes more sense. Yeah, emit enum. We might skip fields. Skip fields. Okay. It's an argument we're passing in saying what fields to skip. And right now we are not passing any skip fields, so I'm going to, if not skip, I'm going to phrase that a little differently. But anyway, none of this matters to us yet, so I'm going to ignore it. Field name, that makes 2 uppercase here makes sense. So we're going to have to copy paste that to uppercase. And again, if you're just joining us, we're working on the Rust client bindings to the Tiger Beetle financial database. And today we're working on creating a bindings generator written in Zig to generate Rust bindings to a Zig library that exposes a C ABI. But mostly we're just kind of looking at the pre-existing work for bindings generators for other languages and copying and pasting and just adapting other generators to the Rust case. All right, and here is the case where it deals with either the enum or the packed structs. For whatever reason, the packed structs goes to the enum case. But for now, we're not dealing with pack struct, so I'm not going to just copy that code that's not going to be run yet. So for every single variant, we're going to emit something that, again, needs to look like bindgen. And that's going to be a variable name, a constant name, with some kind of type and some kind of value. And let's again go look at the bindgen code. And where was it? Somewhere up here. So the bindgen prefixes all these constants with the name of the enum, the name of the variant. It's not the name of the variant. What is this? TB create account. Result. Let's go look at the Zig declarations. Create account result. Create account result. Create account result. TB create account. I'm just wondering right now where this TB create account came from. There's OK. I bet this is an artifact of the way the C bindings generator works. Field name, C name. Yes, C name. It's actually Rust name. So when we called emit enum, we passed, what is this C name? This should all be Rust name, not C name. The type mapping. So up here, I'm expecting C name is TB create account result. Still don't see where this TB create account came from. TB client.h, TB create account result. Yeah, it's right there in the C code. TB client header. It is that C name. All right. I've got a bit of a mess going on right now. I'm making multiple changes that are somewhat unrelated. It's Rust name. Rust name. C name. That's the suffix. That is what the suffix thing is. Why? I wonder why it did that. So this is stripping out part of the C name that's passed in, and that's why it doesn't have create account result on it again. Unclear. Unclear why it's doing that. It is clear more or less what it's doing now. But for now, we have to generate the exact same names as the C bindings generator. All right, so here we had to do the same thing of stripping a suffix. No, Siam says it has to be in line because it's a comp time parameter. Yeah, I kind of understood that well. Siam is responding to like why there's doing an inline for here, because this type info is comp time. I don't really grok fully why you have to hint to the compiler that this is a comp time loop. Don't quite understand it, but like when you're looping over a constant, you have to use inline for. Thanks, no Siam. Hey, throw it pies. I'm just working on making a new bindings generator for the Rust client right now. All right, so the suffix thing, we got to do something like this. And again, we're using a Rust name. Yeah, unclear why it's decided, why they did that. So now we're stripping off that part of the name, so we should end up with the same name, field name. And then this syntax, we're missing this type right here. So right here, we need to also insert the type of these constants. And these are going to be uints, I think. But let's go again, look at the Rust code. tbclient.rs. Oh, no, they're not uints. I mean, they are. This is an alias for a cuint. But for readability, we need to output the type alias. And our type alias is that Rust name. So here we just put Rust name. Okay, I'm going to contend that this is correct, but we'll see. Barring any local variables never mutated. Okay, that seems fine. Let's go look at our new bindings. Look at that. Look at that. That all looks more or less right. TB create account result. Looking pretty good. We're making progress. All right, let's checkpoint that work. I'm not feeling very good about the quality of this code. I'm just kind of blindly copying stuff and like pretty easy for this code to go off the rails if any of these input types change. Yeah, who needs bindgen? It's interesting, we're throwing away like a bindings generator that is kind of rock solid and then writing our own not very good bindings generator. Or at least a bindings generator that I don't have confidence in and that is kind of tailored to exactly the types that are being thrown at it. Okay, so this create accounts result worked. And that is probably enough for us to generate some other types. So real quick, let's just see what other things can be generated correctly. I bet that will generate correctly. TB create accounts result T, that's a struct. Flags we can't do. TB operation, what is a TB operation? Let's go back to the Tiger Beetle code again. TB operation. Oh, no, this isn't in Tiger Beetle. This is in tbclient.zig. TB operation T is a state machine operation. So the question in chat is, since I'm removing bindgen, why am I duplicating the bindgen style? And that is a good question. And the reason, I'm going to switch back to camera and take a break for a second. The reason that I am exactly duplicating bindgen style is just for sake of refactoring. So I'm going to generate what bindgen generates, then I'm going to throw away the bindgen code, but all of our existing bindings code will still work. So we're going to have a working new bindings generator, and then I'm going to come back to the bindings generator, and I'm going to maybe then change the binding style to emit something more Rust idiomatic. So just doing it in 2 steps. So I don't have to like change the whole world at once. I want I want the Rust crate, all the Rust API code to still work just with a new bindings generator. And then we can come back at a next step and slowly tweak the exact output of the bindings generator to maybe look better. And probably we'll have to do that step because I suspect it won't get through code review if it looks the same as bindgen, because bindgen's output here looks pretty darn ugly. But yeah, the end result is that we are going to get some slightly more Rust idiomatic code. And from the review, I don't know if you were here yesterday, no, Siam, but Alex, the reviewer, wants us to expose those C types directly to the Rust API. So we are going to need to have some attractively defined C types in Rust. Whether they are the types emitted directly from the bindings generator or whether they're kind of written by hand and then transmuted back and forth, mem copied back and forth, I don't know yet. I'm in general not in favor of exposing generated code directly. I almost always prefer to wrap it so that I am in control of the presentation. And I talked about that a lot during this previous streams. And that was kind of why I did what I did with the Rust API, where I didn't expose any C types. But that is actually not what we want to do in the end. We want those C types to go all the way up to the surface of the Rust API. I am not sure how much longer I'm going to last here, guys. It's been about 2 hours. Yeah, so in general, if I'm doing a refactoring, I often want to like break it down into small digestible steps and just changing the bindings format, output format at the same time as writing a new bindings generator. This feels like a big step. I'd rather break that down into smaller steps. Which I think is fine here because this bindings generator, again, it's just a few hundred lines. So it's not going to be too difficult to write it twice, basically. Let's see, what was TB operation? All right. I don't really care about going and looking at these other enum types right now. I do think I'm going to have to take a break. I'm just kind of toast. We'll come back tomorrow and maybe deal with this flags. This flags in the C generator follows a similar code path to the enums. So we can probably tackle that pretty fast. It's going to take at least one more session to get through this. All right, I'm going to just checkpoint where we are and we're going to wrap up. Don't need to keep that. See if I push this. No, git push. Why does my hand hurt? Origin, no person. I'm setting the upstream on my new branch here. Yeah, I took several weeks off because I was just basically afraid of coming back to this PR and like dealing with the rework and dealing with the review. But pushing through it now, so we're going to be back to streaming pretty regularly. Again, my name is Brian Burson on GitHub, BRSON. You can find my socials on my GitHub pages probably. We're doing this project, and I'm going to be back to doing this every few days. Don't have a set schedule, but I usually announce 10 minutes ahead of time on Slack and other places. I appreciate everybody showing up today and helping me out. It's been great fun. Thanks. I'll see you next time.